Hello everyone, welcome to my channel. So here we are at the part 3 proof of some special integral. We are going to discuss the last three proof. So let's just start. Is equal to integration 1 upon square root of x square minus a square dx. We are going to solve this and let's see how we can prove this. Okay, so for this again we are going to need a help of trigonometric ratio, that is x is equal to a sec theta we are going to use. Okay, taking the derivative on both sides, that gives you the derivative of sec is nothing but sec theta into tan theta d theta. Okay, also we can find the value of this theta, but later on I will just write it. Okay, now again let's take the value of I and let's just substitute here. So the value of x will be a sec theta square minus a square, and the value of dx will be a sec theta into tan theta d theta. Okay, then this will be a square sec square theta minus a square, and in the numerator that will be same. You just have to repeat it. Now you can see we have the a square common. We can take the a square, so you are left with sec square theta minus 1. Again you have to repeat this part in the numerator. Then I is equal to, so the square root of a square is nothing but a, and the square root here sec square minus 1. So here the value of sec square minus 1 is tan square according to trigonometric identity, and in the numerator it will be same. Okay, so the a and a will get cancelled. Now we are left with the integration 1 upon tan square, that gives you tan, and in the numerator you are left with sec and tan. Again tan and tan will get cancelled. You are left with integration of sec theta. So we have the integration of sec theta, we have the formula, that is log of mod sec theta plus tan theta d theta plus c, integral constant. Okay, now we will use the value of theta from here, the value of theta, or you can see find the value of sec theta. Let's say sec theta, that will be what, x upon a, because you have to find the value in the terms of x and a. Okay, so we can just substitute here, the value of sec theta will be x upon a. Now the question comes here, what will be the value of tan? Okay, so for that we are going to use a trigonometric identity. Okay, so for that let's just take you on the next page. I'll explain it over here, then we'll come back here. Okay, so now we have the trigonometric identity as 1 plus tan square theta equals to sec square theta. Okay, now the value of sec square, or the value of sec, is x upon a, the whole square, and this will be minus 1, and this is tan square. So the tan value would be what, square root of x square upon a square minus 1. This is how we can find the value of tan. Okay, if you just do this LCM, you will get x square minus a square upon a square. So this will be the value of tan. We can just substitute over here, under root of x square minus a square upon a square mod plus c. Okay, now we can take x upon a, we can take the square root of denominator, because in the denominator we have a square, so the square root of a square will be a plus c. Okay, now let's just move on to the next page. So we have the common denominator as a. Okay, if you want I can just write it here. x plus square root of x square minus a square upon a mod plus c. We'll take this on the next page. So that gives you, we have already integrated it, log of x plus x square minus a square minus log of a plus constant. Okay, now why I have done this, how we have done this, we have applied the formula of log of a upon b, which is log of a minus log of b. So if you can see, we had log of, in the numerator we had this, and in the denominator we had a, so we can write log of numerator minus log of denominator. Okay, now if you can check this out, since this is a constant, a is also a constant, but we taken the log, so that also becomes a constant. So overall this whole things comes out to be constant. So you can replace it with another constant here. So that gives you log x plus mod of x square minus a square plus, we can take a capital C, where we will define capital C is equal to c minus log of a. So this is how we have proven this. Okay, let's just move on to the next one, which is I is equal to integration 1 upon square root of a square plus x square dx. We have to prove this. Okay, so for this we are going to use a substitution of, again, x is equal to a tan theta. Okay, let's just take the derivatives. That gives you dx is equal to a, the derivative of tan will be sec square theta d theta. Okay, let's just substitute over here. That gives you 1 upon square root of a square, and the value of x will be a tan theta square, and the value of dx will be a sec square theta d theta. Okay, now this gives you a square plus a square tan square, and this is a sec square d theta. Again the numerator will become same. You can take the a square common, so you are left with 1 plus tan square inside, and again in numerator gets repeated here. So here we are integration 1 upon the square root of a square will be a, and the the square root of 1 plus tan square. 1 plus tan square is nothing but sec square theta. You already know this. Okay, now this a will get cancelled, and we are left with square root of a sec square is again sec, and this is sec square d theta. So 1 sec will get cancelled from the numerator, we are left with sec in the numerator. Now again we have got the value of sec theta. So the value of sec theta we have already discussed, which is nothing but log of sec plus tan plus c. Now here the value will be the same, okay, because we are having the same substitution, okay, but a little bit different. How? Let's just see. So here we can see that the value of tan theta coming out to be x upon a. So instead of tan you can write x upon a. Now what will be the value of sec? Let's just see. So we will take it on the next page. Again 1 plus tan square theta equals to sec square theta, right? So the value of tan we have already found out, which is x upon a, and the square, this is sec square. So the value of sec will be square root of 1 plus x upon a square and square. You can take the LCM, that gives you a square plus x square upon a square. So we have got the value of sec. Let's just substitute here. So which is nothing but square root of a square plus x square, a square plus x square upon a square. Okay, log, again we can take the square root of a square in the denominator, so that gives you a, and this will be same. Now we have the same denominator, common denominator as I say, so that gives you x plus square root of a square plus x square. Okay, again we will apply the same log formula, log of a upon log of b, that gives you I is equal to log of mod x square plus a square plus x minus log of a plus c. Okay, so we are done with the proof, but since here this is also constant, this term is also constant, so we will replace this whole part with another constant. We can just replace it with capital C, that is plus c, capital C. Okay, and this capital C will be equal to minus of log a plus c. So this was how we have proven the second proof. Okay, now we will do the last proof of this. So let's just move on to this. I is equal to, I hope you have understood the first two proof because it was very much similar. Okay, now this is something different, but it is also very easy proof. 1 upon x square root of x square minus a square dx. Okay, we are going to use the substitution x is equal to a sec theta. Okay, so the theta will be coming out, or we can just write it on the other side, that gives you theta as sec inverse x upon a. Take the derivative of x will be 1, and a, the derivative of sec will be sec into tan into d theta. Okay, let's just substitute here, that gives you 1 upon, the value of x will be a sec theta square root of, that is a sec theta square minus a square, and the value of dx will be a sec theta into tan theta into d theta. Okay, now a sec theta and a sec theta will get cancelled from the numerator. We are left with denominator as a square sec square theta minus a square multiplied with the tan theta in the denominator. You can take the a square common with the square root also, that gives you a, so you are left with sec square theta minus 1 tan theta in the numerator. So that will be integration 1 upon a, and the sec square theta minus 1. Okay, sec square theta minus 1 is nothing but tan square, and here it is tan theta d theta. So 1 upon a, square root of tan square is tan, and here also we have tan. This will get cancelled, we are left with 1 upon a, we can take outside, the integration of 1 d theta, that is theta plus c. We can substitute here, which is nothing but sec inverse of x upon a plus c. Okay, so this was the last proof of all of the 7. I have completed it in 3 parts of the video, part 1, part 2 and part 3. So total we have covered total 7 special integral proof which may come for your board exam. So just make sure you check out all of these videos and practice for your board exam. Okay, and wish you luck. Thank you for watching this video. Have a good day.